Hello, everyone, and welcome to today's Energy Storage News webinar with Twice, where we'll be looking at the important role battery analytics software plays in improving the performance, availability, and safety of battery energy storage systems. I'm Andy Colthorpe, editor of Energy Storage News and deputy editor-in-chief at Solar Media, which publishes ESN along with other industry-leading titles, including the world's first and best solar technology website, PV Tech. Now, that's perhaps worth mentioning because Energy Storage News began life 10 years ago as an offshoot of PV Tech. At that time, battery storage systems for the grid were only being deployed by the handful, even in the most advanced markets, and average project sizes were much, much smaller than they are today. But the increasing importance of storage to the solar industry was something our company could see on the horizon. Today's utility-scale battery energy storage system, or BESS, assets are typically 10 or even 100 times bigger than the projects we would be writing about back then, when anything over a megawatt or a megawatt hour was considered large scale. And in most of the markets we cover for ESN, BESS assets are no longer just pilot projects because the value they bring in providing flexibility and resilience to electricity networks has long been proven. There are, of course, still emerging markets at state and international level, which are still at an earlier stage in their journey, but we can see that the fundamental drivers will likely be the same, especially where adoption of renewable energy is picking up speed. And in mature markets, which include the US, Australia, the UK, and much of the rest of Europe, BESS assets are generating revenue because of that proven value to utilities, grid operators, and communities. For example, we'll be hearing about how battery storage operates in Texas's ERCOT market during today's session. One industry contact I spoke to last year, who is themselves from Texas, told me that they are proud to be working to deploy a technology that doesn't just make money for its owners and investors. And to be clear, there is very good money to be made, but that also proactively helped Texas ride out some of the most challenging conditions the ERCOT grid has faced in recent extreme weather situations. And while the relationship between the BESS and solar PV industries remains a synergistic and important one, something another source told me early on in the life of ESN has stuck with me ever since. They said the market operation and therefore business case for battery storage is far more complex than it is for renewable energy. Whereas utility-scale solar PV and wind plants generate power, which is then sold, BESS assets stored energy can be used smartly across a variety of different applications. And that can include a dozen or so grid services, as well as capacity and energy trading. Not being able to successfully navigate those markets therefore risks the business case for your investment. While in some of our previous webinars, we've heard about how important route to market optimization of assets is in that journey, today we'll be learning about how cloud-based battery analytics can be applied to ensure those assets will be available at the highest performance and safety levels to meet the needs of the market opportunities they will be playing into. Today's speakers from Twice are Leonard Hinrichs, Executive Vice President and General Manager for Americas, and Ryan Franks, Senior Technical Solution Engineer. Now, as always, interaction with you, the audience, is really important to us. And the presentation from Leonard and Ryan will be followed by a Q&A session. So please do put your questions for the speakers into the questions tab that you can see on the right-hand side of your screen. Now, we'll try and get as many of your questions answered as possible during the short time we have allotted, but Twice representatives will be happy to reach out to you and reply to any that we don't have time to cover in this session. And finally, from me, today's webinar will be recorded and made available to registrants on demand at Energy Storage News. So with that, it's my great pleasure to hand over to today's speakers, Leonard and Ryan. Over to you.
Thanks very much, Andy. I'll just briefly introduce myself here. My name is Ryan Franks. As Andy said, I'm a Senior Technical Solution Engineer at Twice, and I've been in the battery and energy storage industry for about 16 years now, primarily doing safety and performance testing, permitting consulting, and techno-economic analysis. Leonard?
Yeah, thank you, Ryan, and thank you very much, Andy, for that brilliant introduction. I think it sets the scene nicely. So I've been with Twice since the early days, 6 years ago. I have since been growing the commercial teams of Twice, and I'm now representing the Americas team here. And I'm happy to guide you through first a bit about what Twice is, but then in particular looking at these markets that Andy described and the relevance of really getting it right in terms of reliability, a topic that I think is top of mind again now with recent news, but also just improving the top line there, top and bottom line there for asset managers and operators. But let's start with a brief overview of who we are as a company. And Twice is really leading the pack here with regards to battery analytics software worldwide. We have 140 people distributed across 3 offices, Munich, and then Ryan and I are in Chicago, Illinois, and we also have an office in Paris. What I think is exciting about Twice is that we take that topic of really understanding batteries, battery performance, battery behavior to the next level. And that's why we have our own battery research center. And the headquarters there sits in Munich. And we do have our own 2 testing facilities here on site in Munich, where we have plenty of testing channels, but we also work with external partners. And we also do that here in the US. So we do actually have local testing facilities. I did claim that we are the leading company in the area of battery analytics, and this is also something that we can back up with the largest patent portfolio in that area globally. We've collected over $90 million in funding to enable the investments into our very scalable platform that we're going to take a sneak peek into later during this webinar. And really, I mean, it's all about customers. It's about who you work, who's using your software. And I think we can be quite proud of the amount and especially the logos that we've collected over the last couple of years. I mean, maybe highlighting here US companies such as Fluence and M&H that you're surely familiar with. We also work with the leading automotive brands in the world and some fleet operators. Quite relevant, I think, also to many of you are topics surrounding insurance and warranties. So that's why we also work together with insurance companies. Just one example here is Munich Re. But we also have our platform certified and also help providing certifications for batteries with TÜV Rheinland here. Let's go into that topic though. And I kind of repeat what Andy said here during his introduction. I mean, we are currently only at the beginning of a huge ramp up of battery storage capacity. There is a 29% increase in the deployments alone. Given that storages are being operated, dozens of years, up to 20 years, I suppose, you can clearly estimate here also the ramp up in live capacity. And that isn't particularly true, of course, for the huge portfolios that are coming live here in the US, but also now increasingly in markets in Europe and Asia. And we're looking at 2 to 3 hours of batteries that are live just in the energy storage market. I'm not including any mobility applications here. And that is huge. That is a scale that needs to be addressed. And any kind of glitches there regarding safety or reliability will cause a huge problems for the market. And just to give you a perspective on what that means technically to have so many storages online, I think, Ryan, you brought a very exciting example on what that means with data points.
Yeah, thanks, Leonard. We took a look at one energy storage system, and we came to the realization that in one day, that energy storage system generated 18 billion data points. And as Leonard was talking about that hockey stick growth and deployments of capacity of energy storage, in 2030, that all of the ESS in the world will generate over 400 trillion data points. That demonstrates the clear need for a platform to be able to organize this data, and it becomes increasingly complex as deployments scale because not everything in a fleet per particular owner, asset manager, or operator is going to be the same type of storage. They're going to be different types of energy storage systems, and collecting those insights and deriving value out of it is untapped.
And this entire topic, using battery data, that's what we are all about. And we take a very holistic approach here. So we look at the entire life cycle of battery management. It even starts in the design phase of battery cells. Then once the storage is being built, the commissioning, and then we're looking at the in-life. It's all about taking the risk out, technical risks, so anything surrounding accelerated degradation, performance-related risk, safety-related risk, but also looking into more financial topics such as having the performance available in the right time so that you can actually generate the top line, but also that you're covered from a warranty perspective. So really what we always say, unleash the full potentials of your battery. Now, we won't touch so much on the safety aspect. There's a webinar that we're hosting soon together with APRI, where we're diving extremely deep into that topic. We've really looked at that as well. But today is all going to be about performance and availability. Also, warranty, another time. If you're interested in that, reach out. We can shed some light on that. But today is all about performance and availability. And let me talk a bit about why that is important. I stole some slides here. Basically, these are slides of Modo Energy. They presented it during the Twice Vision Summit just 2 weeks ago. So if you're interested in that, the video recording of Quentin is also available on our website. He talked about general availability and what that means for revenues. And this graph here shows that clearly 3 storages here to the left in ERCOT did a fantastic job. They were available 100% of the time. But we also see some storages here on the right that were only available 60% of the time. This, by the way, is Great Britain ERCOT, if you're wondering what it is. So we're looking at an average here that is very high in the 90s, 97, 98% availability in these 2 markets. Why is that a topic? I mean, one, if you're not available, you can't generate revenue. That's clear on a personal level, on an organizational level. I think on a more holistic market level, it's something that we see news about. For example, in ERCOT, just recently, the topic surrounding NPRR 1186 that got rejected, but basically trying to address these topics surrounding reliability and storages not being available to deliver the energy that they were supposed to deliver. That is a problem because it destabilizes the overall market and system. But kind of going into the topic of what that means on an organizational level financially, it's very interesting to see and compare different markets as well. I know we have an international audience. We had this discussion with Andy before. Europe is strongly coming, UK as well. So here's an example from the UK. Fairly well distributed across all 360 days of the year. You clearly want to be in these high revenue periods. That is a couple of days a year where you generate in excess of $500 per megawatt. But also, it's fairly kind of evenly distributed. The x-axis, that is just the x-axis, is referring to individual storages that were analyzed. So every bar here represents one storage. And here, the x-axis is days. And they're not days across the year, but they are just allocated the most revenue generating days here to the right. And this is fairly even. I mean, you have low revenue days, you have high revenue days, but fairly even. Look at ERCOT. ERCOT is a bit different. 13 days a year generate 50% of the revenue, just because of the nature of how the market is set up and the heated periods in the summer. We come to that. But a lot of other days are actually generating less than Great Britain. So really managing your availability and being in the market with your asset when these high price peaks hit. So this is what we are seeing here. So during the summer month, here also September, and maybe on the shoulder periods here as well. So there's some peaks, as Quentin calls them, the spiky bits. You want and need your storage to be ready in order to really generate the revenue that you need. And that can be financially, huge. So 1% in availability is worth over $2,000 per megawatt. And how we address this and how we can help you achieve this 1% percentage point availability, Ryan is going to guide you through that a bit more on the more technical aspect.
Thanks, Leonard. So yes, we've really, almost nobody that we've talked to in the past few years has not had some sort of an availability issue. But what that really gets down to is I might know I have a problem, but what do I do about it? And with battery analytics, what you're able to do is inform maintenance practices, pinpoint where these availability problems are stemming from in the system, and be able to identify the root cause that is causing that issue. And furthermore, extend the lifetime in addition to just making increased revenue on an annual basis, avoiding areas of the battery that are cycling and degrading much faster. And we do that with Performance Manager. So this is a view of our web platform and our Performance Manager suite. And the entire point is to be able to pinpoint where problems are occurring. The delta here is, again, it's one thing to know on a system level basis, though it's individual bar lines that Leonard was talking about in those previous slides. It's an entirely different thing to be able to dive into correlations between the twice calculated state of charge and the other KPIs that we're looking at, temperature, voltage, DC resistance, and others, to be able to, at the very granular level, say this particular element of the DC storage block is causing the issues and trigger a long-term service agreement clause or other remediation action. But just so we're all on the same page here, one of the primary causes of inavailability is imbalance issues. Imbalance issues at either a module level or a string level. And if you look to the chart on the right of this graph, or the graph on the right of this chart, I should say, if you start at the center and you go to the right, what is occurring is that elements of the battery are having their SOC, their state of charge, reported inaccurately. When you go and charge, not all of the capacity is able to charge to the complete set point, 100%, for example. If you go to the left and discharge, not every element of the battery is able to discharge to its complete extent, leaving a lot of usable capacity on the table. Ultimately, weak cell imbalance issues cause this. It's dangerous in some respects because overcharging can occur if the SOC is reported inaccurately. And furthermore, the point of this is to be able to, again, not at a system level, but at a very granular level, determine what's occurring. So if we look at the thermal, one other thing is thermal analysis in this. So if you look at thermal analysis, this is a heat map from our energy performance platform. And we can distill what the temperatures as well as the temperature spreads are like inside of this system. High temperature is often a warning sign of a particular problem being displayed. And this platform allows you to dive in and experience what is actually causing this problem, leading to the rectification of the issue. But back to availability, let's take a look at one case study here. So this is from about a 400 megawatt hour energy storage system. It was expected to make $10 million in revenue on an annualized basis. Unfortunately, it was missing its revenue target by about 10%, $1 million per year. Both the integrator and the project owner and operator were unable to determine the cause of this, and they approached twice. And what you see in front of you is some instances of the type of data that can be generated off of this. The chart on the top of this slide details the problems that were occurring. And in the dark blue, you can see instances of problems that were done at a daily basis. And in the light blue, you can see instances of problems that spanned multiple days. The x-axis on this is month, and the y-axis is number of events. This helps suss out what elements of the battery were experiencing periodic things versus what elements of the battery were experiencing long duration incidents that occurred over several different time periods. The chart on the right is as an example of a snapshot from the month of October of last year. And on the y-axis, you have location, battery container. And you see a heat map there of the average availability, red being bad. And you can clearly see inside of this throughout all the time periods beyond the month of October, specifically what elements were having unavailability problems. The result of this was that the owner of the system was able to engage with their integrator. In fact, they were quite on board with it to be able to solve these problems, to begin a process of targeting certain elements of the battery for module replacement, taking balancing actions, and ultimately leading to a much higher revenue for a pretty quick return on investment, actually. But here's a quote from a senior director of asset management. This is a very experienced firm, a spin out of corporate interests. And they say that availability is critical for us. We see revenues underperforming, and the first thing we want to check is availability. To highlight just one other thing on the dangers of degradation at misreported SOC levels, if you go into this platform and are able to dive into the data explorer elements of what we're doing to get to all the data that is behind these visualizations and insights, you get instances like this. On the y-axis, you have the SOC, and on the x-axis, you have time. And the ideal case of an energy storage system, and this is a 320 megawatt hour energy storage system that had been in operation for some time. The ideal case would be that all these lines match up. The SOC should be the same as it moves across as you probe around the different elements of this DC storage block. But they're not. You see that there are some of the blue lines that are exceeding the SOC set point. At that level, what you experience is increased cycling and increased degradation, and the potential for overcharging if it goes above 100%. Leonard?
Sure. So that brings us back now, right? I mean, kind of trying to complete the picture here. Deep dive on availability and performance. Please put your questions out there, and it's going to come back on live for a second. But it's about addressing all these challenges surrounding the lifetime. So I just want to kind of wrap it up, bring it back to the high level here. And clearly, we talked about this. Planning phase, there's our cell or our battery simulation software. We have deployment with the digital commissioning, baselining your storage, pinpointing to weak spots, making the physical on-site commissioning a lot smoother, and then our different solutions during the operation to address topics like performance and availability, but also like safety, accelerated degradation, and so on, until decommissioning. Now, a lot of people often ask, well, what's the difference with BMS, EMS? What is analytics? Why is it what we call the layer on top? And Ryan and I tried to make an effort here of making that a bit clearer. So while the BMS is kind of on the battery, doing the measurement, balancing the battery, it's kind of battery state control on the very granular level. The EMS aggregates this, brings it into the cloud, connects it to other systems, enables it to be controlled and steered. Battery analytics actually offers you this next layer of really understanding, with a lot of computing behind it, the trends, identifying the root causes of what is going on in the battery, enable you to forecast all these complex parameters and really move from a reactive behavior to a proactive behavior to ensure that you're always live and that you're in control. And I'm just sharing this picture here, which is a high level, marketing ready, as our CTO put it, a representation of our platform. So we use battery data. We use the data of the BMS that is being transferred to the cloud by any kind of EMS or telematics device. But then you get chaos. You get data that is clear, not clear. There's a lot of wrong signals in there. So we cleanse the data, we put it into storage, and then we have this middle layer, which is the analytics suite. And that is really where all the topics surrounding operational characterization, health determination, forecasting, incident detection, incident forecasting, and everything happens to bring that to you through different user interfaces. And that can be our web UI that we, for ease, usually use here in these webinars to show, but that can also be an API into your systems. And this platform really can be applied to any scale or size of batteries. It's extremely robust. It is extremely scalable. So we can onboard gigawatt hours of storages within days. and then make that available to you. There's also certification surrounding this. So we are really enterprise ready with this product and can provide that service to you. And with that, I think we have at least 5 minutes for Andy to grill us with your questions.
Indeed, yes. At least 5 minutes, I think. Yeah, we'll tackle as many of these questions, I say, as we can. And also, actually, to both the speakers, if maybe some of these questions are perhaps a little bit too much, require a bit too much detail to go into here, then yeah, feel free to reluctantly decline and reply to them offline, I guess. But yeah, without further ado, let's get into these. And the questions are still coming in as well, I should note. So do keep them coming, because, as I say, they will get answered either now or later. But yeah, really fascinated to see them come in. So thanks so much, everyone. So Eric from the audience asks, how do you calculate the availability? Is it based on a specific indicator? Does it perhaps depend on the expected services that the batteries should be providing? So I guess, availability is increasingly an important KPI, but yeah, how is that kind of assessed?
Yeah, happy to take that. So yes, availability is calculated as the time that the system, the capacity and the time that the system should be on versus what it was actually able to charge and discharge in capacity and the time that it was on. When you get into NERC definitions, you find out there's a lot of political games in terms of essentially classifying certain events as scheduled maintenance, scheduled downtime versus not. But the takeaway should be, was the system on and delivering the power and the capacity that it should have for a given period of time?
Okay, yep, thanks very much for that. And there's a couple of questions here about how the data is accessed and measured. And Leonard, I think you did allude to that briefly in terms of it being, telemetry from the BMS. But yeah, so if I can just ask these two questions sort of in one, and we'll see how we get to. So Todd asks, what level of data access do you require to analyze battery performance? And notes many integrators are protective of cell or even string level data as proprietary info. And then Mohammed asks, says that not all manufacturers publish intrinsic data about cell and string level. How does your software or analytics platform cope with this challenge?
Yeah, happy to take that as well. So fundamental battery analytics is a merger between data science and battery expertise. Data is critical. The information on the individual cell specifications is not of much importance because we are using live data. This is information that is coming off of an energy storage system. And to the other points of that question, the way the ideal data that we have is 2-second resolution on voltage, current, and temperature. Happy to get into that in a more thorough discussion. And the way that we get it is from either the site individually or from a database or historian functionality, and transmit that to our cloud for processing.
Well, I think also we should highlight here that we've seen cases where the data was less granular or less frequent. It doesn't mean that we can't work on it. I mean, there's just the warranties that we give on the accuracy of our analytics and how quickly we can onboard and deliver our analytics. That is obviously determined by the ease of access to the data. But I don't think we've had the incidents with any storage where we weren't able to ultimately deliver some kind of analytics.
Okay, and sorry, on a related note, Jarno, I'm sorry if I've got your name wrong there, but thank you so much for your question, Jarno. Says, sorry if I missed it, but how many parameters of different kinds do you read from a BMS? So I presume it's not all 18 billion data points at any given day, but yeah, roughly, what sort of parameters do we want to be thinking about?
Yeah, well, I mean, it really is that many data points, which underscores the reasons why this is not something that can easily be addressed in Excel or Microsoft BI or some sort of platform, some sort of other non-proprietary data platform. Yes, again, voltage, current, and temperature, and wherever it can be measured. So the concept is to go in a Russian nesting doll fashion, to go from site to inverter level to string level to module, and if they should be present, cell level data.
Okay, terrific. Thanks. And Stephen asks, so slightly away from, I guess, the main topic of today, which is kind of more about availability, but I think we did mention safety earlier on, so I think it's good to address this question from Stephen. So Stephen, thank you, and thanks to all of you for your questions, of course. But yeah, Stephen asks, are your customers using your analytics tools more for performance optimization or for safety purposes? And yeah, I mean, I think if that's, just a way to just briefly touch on the role, I guess, of analytics in that safety piece in tandem with performance and availability.
Yeah, no, really good question. Happy to answer that. So the way that I approach this is that safety is frankly hard to put an ROI on, right? You either have an incident and it was prevented and you have a positive ROI, or nothing perhaps happens and it could be deemed a waste of money. But safety comes along. I mean, the way that this analytics pays for itself is through the increased revenue generation opportunities and avoidance of penalties, depending upon the market in energy storage systems. Safety sits on top, and in safety, we're really doing three things. We're looking at thresholds, whether these KPIs cross thresholds. We're looking at statistical analysis of whether one element of this battery deviates from the mean behavior of a system. And we're looking at the time derivative of that. Is the problem getting better? Is it getting worse? Or is it staying the same?
Yeah, I think it's an interesting question. And like the way, from a not so technical standpoint, what is interesting about it is it depends on the customer as well. Like if you've had safety incidents in the past, or you know that you were close to it, that might be more top of mind compared to companies that are just getting started with storages that are more concerned about making sure that they get the money out of them. And what is also missed, and I think Ryan touched on this, but I want to kind of highlight that again, availability and safety are very closely linked to each other, because you do have safety features in your battery that should avoid most catastrophes being an actually burning storage. So all of these systems mean that usually nothing happens, but what can happen is that parts of the system or the entire system shut down because the BMS regulates it, or because other systems jump in. And to prevent that, because you identify the issue earlier on and you can conduct maintenance, also means you're increasing availability and the reliability of the storage ultimately.
Awesome. Okay, so hey, listen, guys. So we've got so many questions coming in that I think, even though we're a little bit over time, let's try and do a couple more, shall we? I think that would be fun. So, so there's one question about one of the case studies that you brought up there, Ryan. So Kelvin was asking about the 400 megawatt hour, which I believe was the first case study that you brought up, Ryan. So in that previous case, Kelvin says, what was Twice's involvement to determine the root cause of an issue that occurred on the 25th? So I don't know if you want to have a quick look back at that slide, or if you've got that in front of you. But how are you able to discriminate between hardware failure, climate interaction, or grid stability?
Yeah. So indeed, what I would point to oftentimes is batteries, sometimes being kind of the victims, not the villains and things. You have this system that is, some of these problems may be attributed to inverter faults, that's for sure. We also take that data into account. But sussing out the issues between what is causing a fault on the DC storage block, what might be an inverter issue, is part of the way that correlations that we're looking at between the battery SOC and other KPIs serve a very needed function. And so specifically in that case study, there was a complete lack of understanding of what this issue was. There had been several rebalancing efforts that had taken place, yet it never seemed to solve the problem because it was not actually rebalancing the system. And so the direct result of that our involvement with that system was to identify the worst availability performance in that system and target it for module replacement.
Okay. Oh yeah, I mean, it's super interesting how you're able to sort of determine all those things with the data available. But yeah, so I think we had a few questions on battery types and cell chemistry. So, increasingly, I think we're seeing the industry, let's say, being dominated by lithium iron phosphate, LFP systems, but then also, there's a lot of systems that have NMC, nickel, manganese, cobalt systems that have already been deployed, and there's still a significant number of those new systems going in as well. So a couple of quick questions. So A. Basner asks, is your analytics, cell chemistry related? NMC, LFP, and so on. Does that kind of make a difference? And what are the differences in how you would analyze those different batteries?
Yeah, so our way of treating data applies to all lithium ion types, NMC, LFP. We've looked at LCA and LTO as well in different applications. It is a lot of our intellectual property is related to how the interdependencies of the electrical, the thermal, and the calendric aging properties of lithium-ion batteries affect and influence each other. So it is not based upon any specific type of chemistry, but it is only applicable to lithium-ion. I will say, however, that in our roadmap and in our plans, we are absolutely on board with addressing the next generation of batteries, namely sodium ion and solid state batteries that are coming to further market prominence in the coming years.
Yeah, I think actually sodium ion is interesting because if you want to learn more about this, stay tuned. I think we're like a month or two out of a release there regarding a base simulation model on sodium ion, which ultimately forms the foundation of kind of assessments for degradations over lifetime. So really actively looking into that. Also got first experience with solid state, of course, as like being more probably on the mobility side, but also that coming up next.
Excellent. All right, cool. Yeah, I mean, we look forward to seeing that. Definitely, I think we're seeing a lot of interest from our readers in sodium ion. I think. Okay, so I think just time for one last question, and it's a little bit of a futuristic question, I think. So. Thank you so much. Thank you so much for asking this one. Yeah, speaking of sodium ion and futuristic things. So, Vuavo asks a question about, how do you think artificial intelligence would be applied to the large data sets being collected? So, I'm guessing some degree it already is, but yeah, what's the potential for that to kind of proliferate?
It's in the name of Twice, right? That's the basis on what we are built on is the AI in the solution. Now, I mean, Ryan, you can probably go into more detail, but I think the important part, if we're looking at AI, and there's so many discussions going on in so many industries, but it's about contextualization. It's a tool that needs to be applied to certain problems and challenges. So just saying any kind of AI company could solve these issues is going to be flawed and won't work. It is about making sure that the AI learns the right way and that with new cells, we are still able to predict elements that are outside what current data sets would provide you. So I saw there were other questions also surrounding lifetime of LFP batteries and whether they would survive 20 years or longer. Well, we don't have data sets on 20 years or longer that we could train AI models with. So that's why it's so important to contextualize it with battery knowledge, to really understand the batteries, to use that research that we are conducting in depth and put it together, combining the AI aspect with the battery knowledge aspect. But Ryan, I mean, please amend this and make it maybe more technical as well.
Yeah, so the fact of the matter is that we go back to all that data, right? And it's oil, right? There's a lot of value that can be found in data, but it's an immense amount. And so the use case for analytics in energy storage is ultimately to serve the higher goal of producing safe, high-performing, high-revenue generating systems. And from the very basic levels of artificial intelligence and data science, such as signal processing, getting clean signals, doing all of that statistical work, up to the very high levels of being able to interact with that data and produce correlations and produce different filtering mechanisms is what makes this so hard, but also very rewarding.
That's awesome. Thanks a lot, Ryan. Yes, and I can't believe I never realized that yeah, the AI in Twice is in fact for stands for AI. Some kind of journalist I am, but you know, I would love to keep answering these questions because I think this has been really illuminating, and you know, I hope you've all enjoyed this as much as we have. But yeah, unfortunately, if you did ask a question, I say unfortunately, you will get it answered, but you will just have to wait just that little bit longer for that answer. So yeah, so with all of that, it just remains for me to thank once again our speakers. Thank you so much, Leonard, and thank you so much, Ryan. It's been a real pleasure.
Thanks for having us, Andy.
And of course, most of all, to thank our wonderful audience for being so attentive, asking some brilliant questions, and I hope you know we've all learned quite a lot from today. So yeah, with all that, I wish you all a great day, and thank you so much for attending.